Hey there, science fans! Welcome to an exciting journey into the world of neural networks. We request you to please subscribe and press bell icon for notification. Have you ever wondered how your phone recognizes your face? It's not magic, it's neural networks at work. Or how virtual assistants like Siri and Alexa understand what you're saying? They rely on neural networks to process and interpret your voice commands. The answer lies in a fascinating field called artificial intelligence, specifically in something called neural networks. These are complex systems designed to simulate human brain functions. Neural networks are like the brains of AI. They consist of layers of interconnected nodes or artificial neurons that process information in a way similar to our own brains. Just like our brains learn from experiences, neural networks learn from data. They are trained using vast amounts of information to recognize patterns and make decisions. They are designed to mimic the way our own brains process information, with layers of interconnected nodes that act like artificial neurons. Each layer processes the data and passes it on to the next, refining the output step by step. These networks are transforming the way we live, work, and interact with the world. From healthcare to entertainment, neural networks are making a significant impact. From personalized recommendations on streaming services to self-driving cars, neural networks are behind many of the technologies we use every day. Neural networks are powering a new era of technological innovation. They are the driving force behind advancements in robotics, natural language processing, and even art creation. So, buckle up, because we're about to take a thrilling ride into the world of neural networks and explore how these powerful tools are shaping our future. Stay tuned for an in-depth look at the incredible potential of neural networks and their role in the next technological revolution. Now, you might be wondering, what exactly is a neural network? It's a fascinating concept that mimics the way our brains work, allowing machines to learn from data and make decisions. Imagine a network of roads connecting different cities. Each road represents a pathway for information to travel. Each city is like a node in the network, and the roads are like the connections between them. These connections allow for the transfer of information from one node to another. In a neural network, these nodes are organized into layers. Each layer has a specific role in processing the information. First, we have the input layer, which receives information from the outside world. This is the starting point where raw data enters the network. Think of this like our senses taking in information. Just as our eyes, ears, and other senses gather data from our environment, the input layer collects data for the neural network. This information is then passed through one or more hidden layers where the real magic happens. These layers are crucial for transforming the raw data into something meaningful. These hidden layers process the information, looking for patterns and relationships. They perform complex calculations to extract features and insights from the data. Finally, the output layer spits out the results. This is where the network's interpretation of the data is presented. This could be anything from identifying an image to predicting the weather. The output depends on the task the neural network was trained for. The connections between these nodes have different strengths. Just like some roads are wider and faster than others, these varying strengths influence how information is prioritized and processed. The strength of these connections determines how information flows through the network, and this is where the learning takes place. By adjusting these strengths, the network improves its performance over time, becoming more accurate and efficient. So how do neural networks actually learn? It's a fascinating process that mimics the way our own brains work. Well, it all starts with data. Data is the foundation upon which neural networks build their intelligence. Just like we learn from our experiences, neural networks learn from the data they are fed. This data acts as their experiences, helping them to understand and interpret the world. This data could be anything from images and text to sensor readings and financial transactions. The variety and volume of data are crucial for the network's learning process. The process of teaching a neural network is called training. Training involves feeding the network with vast amounts of data and allowing it to learn from it. During training, we feed the network with labeled data. Labeled data means that each piece of data is tagged with the correct answer. For example, if we're teaching it to recognize cats, we'd show it thousands of pictures of cats labeled as cat. This helps the network to understand what a cat looks like. As the network processes this data, it adjusts the strength of the connections between its nodes, trying to minimize errors and improve its accuracy. This adjustment process is known as optimizing the weights. This process is repeated over and over with the network constantly refining its understanding of the data. Each iteration helps the network to become more accurate. The more data we feed it, the better it gets at recognizing patterns and making accurate predictions. Large data sets are essential for the network to learn effectively. It's like practicing a skill. The more you practice, the better you become. Similarly, the more a neural network trains, the smarter it gets, continually improving its performance and accuracy. Section 4. Neural networks in action. From voice assistants to self-driving cars. Neural networks are not just a futuristic concept, they're already deeply embedded in our lives. Remember those voice assistants we talked about earlier? They rely heavily on neural networks to understand your commands, translate languages, and even generate human-like text. Ever wonder how your social media feeds know what you'd be interested in? Neural networks. They analyze your past behavior and preferences to curate a personalized experience just for you. And don't even get me started on self-driving cars. These marvels of engineering use neural networks to perceive their surroundings, make decisions in real time, and navigate complex environments. From healthcare to finance, entertainment to security, neural networks are revolutionizing industries across the board. Section 5. A history of innovation from humble beginnings to powerful AI. The story of neural networks is a long and fascinating one, dating back to the mid-20th century. It all began with the idea of creating artificial systems that could mimic the human brain. Early pioneers in the field developed the first artificial neurons, but these early models were limited by computational power and data availability. However, as technology advanced, so did the capabilities of neural networks. The development of new algorithms, coupled with the exponential growth of data and computing power, led to a resurgence of interest in neural networks in recent decades. This has paved the way for remarkable breakthroughs in artificial intelligence, enabling machines to perform tasks that were once thought to be the exclusive domain of humans.